Greetings everyone. This is an informational presentation on GSM architecture by Sailesh Mane, Abhishek Mal and Namrata Anand Kumar. This presentation outlines introduction and history, GSM architecture, implementation, technology and standards, summary. What is GSM? GSM is a standard set developed by European Telecommunication Standard Institute (ETSI) to describe protocols for second generation 2G digital cellular network used by mobile phones. When was it developed? It was developed as a replacement for first generation 1G analog cellular network and originally described a digital circuit switch network optimized for full duplex voice telephony. Improvements in GSM. This was expanded over time to include data communication first by circuit switch output, then packet data transport via GPRS general packet radio services, and Edge, enhanced data rates for GSM evolution for eGPRS. Further improvements were made when 3GPP developed third generation UMTS standards followed by fourth generation 4G LTE standards. Now let's have a look at the GSM history. Early European analog cellular network consisted of a mix of technology and protocols. In 1983, work began to develop a European standard for digital cellular voice telephony. Phase 1 of GSM specifications were published in 1990. In 2000, the first commercial GPRS services were launched and the first GPRS compatible handsets became available for sale. In 2002, the first multimedia messaging services were introduced and the first GSM network in 800 MHz frequency became operational. By 2005, GSM network accounted for more than 75% of the worldwide cellular network market, serving 1.5 billion subscribers. The GSM Association estimates that the technology defined in the GSM standard serves 80% of the global mobile market, encompassing more than 5 billion people across more than 212 countries and territories, making GSM the most ubiquitous of many standards for cellular network. GSM, Global System for Mobile Communication. This is the basic architecture of GSM. Confused? Well, let's get familiar with the fundamental concepts of GSM.
Information on GSM architecture. A GSM network consists of following components. Mobile station. The GSM mobile station or mobile phone communicates with other parts of the system through the base station system. Base transceiver station (BTS). The base transceiver station handles the radio interface to the mobile station. The base transceiver station is the radio equipment. Base station controller (BSC). The BSC provides the control functions and physical links between the MSC and BTS. It provides functions such as handover, cell configuration data, and control of RF power levels in base transceiver stations. A number of BSCs are served by a MSC. Mobile Service Switching Center (MSC). The MSC performs the telephony switching functions of the system. It also performs such functions as stall ticketing, network interfacing, common channel signaling, and others. Home Location Register (HLR). The HLR database is used for storage and management of subscription. The Home Location Register stores permanent data about subscribers, including a subscriber service profile, location information, and activity status. Visitor Location Register (VLR). The VLR database contains the temporary information about subscribers that is needed by the Mobile Services Switching Center (MSC) in order to service visiting subscribers. When a mobile station roams into a new mobile service switching center area, the Visitor Location Register connects to the MSC, will request about the mobile station from the HLR, reducing the need for interrogation of the Home Location Register (HLR). Authentication Center (AUC). The AUC provides authentication and encryption parameters that verify the user's identity and ensure the confidentiality of each call. The Authentication Center also protects network operators from fraud. Equipment Identity Register (EIR). The EIR database contains information on the identity of mobile equipment to prevent calls from stolen, unauthorized, or defective mobile stations. Message Center (MXE). The MXE is the node that provides integrated voice, fax, and data messaging. Mobile Service Node (MSN). The MSN is the node that handles the Mobile Intelligent Network (IN) services. Gateway Mobile Services Switching Center (GMSC). A Gateway Mobile Service Switching Center (GMSC) is a node used to interconnect two networks. GSM Interworking Unit (GIWU). The GIWU consists of both hardware and software that provides an interface to various networks for data communication. Through the GSM Interworking Unit (GIWU), users can alternate between speech and data during the same call. Subscriber Identity Module (SIM). One of the key features of GSM is the Subscriber Identity Module, commonly known as SIM card. The SIM is a detachable smart card containing the user's subscription information and phone book. This allows the user to retain his or her information after switching handsets. Alternatively, the user can also change operators while retaining the handset simply by changing the SIM. Some operators will block this by allowing the phone to use only a single SIM, or only a SIM is issued by them. This practice is known as SIM locking. Operation and Support System (OSS). The OSS is the functional entity from which the network operator monitors and controls the system. The purpose of Operation and Support Systems is to offer support for centralized, regional, and local operational and maintenance activities that are required for GSM network.
GSM Architecture. In GSM system, the mobile handset is called Mobile Station (MS). A cell is formed by coverage area of the base transceiver station (BTS), which serves the MS in its coverage area. Several BTS together are controlled by one base station controller (BSC). The BTS and BSC together forms the base station subsystem (BSS). The combined traffic on the mobile station in their respective cell is routed through a switch called Mobile Switching Station (MSC). Connection originating or terminating from the external telephone PSTN are handled by the dedicated Gateway Mobile Switching Center (GMSC). The architecture of the GSM system is shown in the figure. In addition to the above entity, several databases are used for the purpose of call control and network management. These databases are Home Location Register (HLR), Visitor Location Register (VLR), and the Authentication Center (AOC), and the Equipment Identity Register (EIR). GSM Carrier Frequency. GSM network operates in a number of different carrier frequency ranges, with most 2G GSM network operating in 900 MHz or 1800 MHz band. Regardless of the frequency selected by an operator, it is divided into time slots for individual phones to use. This allows 8 full rate or 16 half rate speed channels per radio frequency. These 8 time radio slots or 8 burst periods are grouped into TDMA frames. Half rate channel use alternate frames in the tuning time slot. The channel range data for all 8 channels is 270.833 kilobytes per second, and the frame duration is 6.415 milliseconds. The transmission power in the handset is limited to the maximum of 2 watts in GSM 850-900 and 1 watt in GSM 1800 and 1900. GSM technology was introduced in 1990. The access method TDMA was used then, and it is still being used. Channel bandwidth of 200 kHz is deployed. The number of duplex channel is 125. User per channel is 8. Speech coding bit is 13 kilobytes per second. Data recording bit is 12 kilobytes per second, and frame size is 4.6 milliseconds. Implementation of GSM. The implementation is done in 2 phases, one at the transmitter end and another at the receiver end. The message that is to be transmitted, usually is in the form of an audio signal, is subjected to voice encoding. Then it is subjected to channel encoding, interleaving, and post generation. The ciphering of the message is also done, followed by modulation and amplification. These 2 processes are done in order to make the signal to be transmitted conveniently over the long distance At the receiver end, after the message is received through the receiving antenna, it is subject to demodulation and deciphering. Channel decoding, deinterleaving, and reformatting is also done to the message, and the understandable form of the message is given for a voice decoding. The message that is extracted from after voice decoding phase is then given to the amplifier, and hence the person at the receiver end hears what the person said at the transmitting end. The various GSM variants are listed in the following table, along with the uplink, downlink, duplex frequencies, total bandwidth, and number of channels. The various variants are GSM 400, GSM 900, also known as primary band, extended GSM 900, GSMR, DCS 1800, PCS 1900. Of all these variants, DCS 1800 occupies the largest bandwidth, that is twice of 75 MHz, while GSM 400 requires just 14 MHz. Now let us summarize what all we have learned till now. We have learned about the network architecture of the GSM model, about the implementation of the GSM model, how it is done at the receiver as well as at the transmitter end, the various applications such as the voice applications where GSM technology is used for making voice calls, as well as in the data application, GSM technology is also used in 3G, GPRS and its services. Thank you so much.